Hello everybody, we've got a fixed beam and we've got three forces acting on this beam. I've got a 20 Newton force, a 10 Newton force, and a 30 Newton force. The 20 Newton force is acting perpendicular at 3 meters away from point A. The 10 Newton force is acting at a 60-degree angle, and that is 6 meters away. And then I've got another one, 30 newtons, and it is 8 meters away, and it is acting at the slope shown. So what I have down here is I've redrawn my beam, and I'm drawing a free body diagram. So what I'm missing here is my AX, my AY, and my moment about A. So we're going to be calculating the moment about A. So when we do this, I've got, so let's just do this. Let's do calculate all reaction forces. So let's just get into this. All my reaction forces here then would be AY, AX, and moment about A. So let's do AX first. So the first thing we need to do then is we need to break these up into their components. So I'm going to draw this one, and then I'm going to have this force as well. And then on this one, I'm going to draw these in green. I'm going to have this one going up. I'm going to have this one going out. So this one here I'm going to have is 30 times 3 over 5, which is going to be 18 newtons. And then my one in the x direction is going to be 30 newtons times 4 over 5, which is going to be 24 newtons. This force here is going to be 10 newtons times, since this is 60 degrees here, this would be cosine, which would be, let me throw this to my calculator. Oh yeah, of course, it's 5 newtons. So this one here is 5 newtons. And then this one in my y-axis is going to be 10 newtons times the sine of 60, and that's going to be 8.66 newtons. So this one here is 8.66. This one right here. Okay, so if I'm solving for my AX, I sum my forces in the x direction. Going right is positive, so I have AX, because that's my unknown. Now this 5 newtons is going in a negative direction, so I say minus 5 newtons. And then this one is going in the positive, which is going to be plus 24 newtons, is all equal to 0. So if we put these together, I get 19, so AX plus 19 newtons is equal to 0. So AX is equal to a negative 19 newtons, or AX is equal to 19 newtons going in the negative direction. If I sum my forces in the y, going up is positive, I have AY, which I am showing positive. I'm assuming it's positive. Then I have 20 newtons, so plus 20 newtons. Then I have 8.66 newtons, so I can add that. And then I have 18 newtons. That's all equal to 0. So if I throw those in my calculator, I get 46.7 newtons. AY plus 46.7 newtons is equal to 0. AY is equal to 46.7 newtons going down, or 46.7 newtons negative. So I have, and then I have this answer here. Now if I sum my moment about A, Now, when I sum my moment about point A, note how AX directly goes into that point, and so does AY. So I don't need to worry about AX or AY since they have no perpendicular distance. But I do assume that moment about A is positive, because I am assuming that it is going counterclockwise. So counterclockwise here is positive. I also have plus 20 newtons times 3 meters. So you notice this is rotating in that direction. That's going to be positive. Then I have this 8.66, which is also going to be going positive. And that's going to be 6 meters away. Then I have these two forces here. So this one is going straight, so it is going through the line of action. So I don't need to worry about that one. But I have this 18 Newton force, so I got plus 18 newtons times, and that is going to be times 678 newtons. And that's all equal to 0. So you have 60 plus 51.96 plus 18 times 8, which is 144. So you get 255. So this is going to be plus 255.96 newtons is equal to 0. That's Newton meter, since we're multiplying a Newton and a meter. Take this to the other side, you get moment about A is equal to about 256 Newton meters negative, or 256 Newton meters going clockwise. So remember, when you're taking your moment, it's always about the perpendicular distance. So this one has this 5 newtons going through that point has no perpendicular distance, and neither does this 30 newtons times 24, 30 newtons, which is 24 newtons in the x direction, also goes through point A, which has no perpendicular distance. So remember, if it makes a rotation in a counterclockwise, that is positive. If it makes it in a clockwise, we call that negative. Now, would you be wrong if you called one or the other negative or positive? No, as long as you're showing me which way it rotates at the end. Some people do say that this is positive, but in my class I will always call a counterclockwise positive. You can also use your right hand thumb rule. If you make a fist and you stick your thumb up like the Fonzie and you close your hand, that is a positive moment. If you open your hand, that is a negative moment. So sometimes you can put your pencil down on your paper, or you can use your hand to figure out which way that force is making whatever beam or object rotate about a certain point or about a certain axis. Okay, that's example 1. I'm going to be putting 2 more up. Please let me know if you have any questions on these. Thank you.